Hello everyone and welcome back to my channel. In this video, we are going to discuss how to do RAG with LangChain. So in the previous video, if you remember, we did the same thing, like we built a RAG pipeline without any frameworks. So if you remember, we just loaded the content, we chunked the text into smaller pieces, then we converted into embeddings, and then we stored the chunks into VectorDB, and then we created the VectorDB and then passed it to OpenAI. So that's what we built in the last session without using any framework. So we built this in plain Python. And today we'll use LangChain for that, and we'll see how it makes our life easier and how we can solve more complex problems if we use LangChain or any similar library like Llama Index. So let's start with the very basics. Like the first thing that we'll do is we'll install the libraries required. Like we'll install LangChain, LangChain OpenAI, LangChain community to use some of their community functions, and then OpenAI ChromaDB. We have used it before as well. So I will just install it. So it's done. And now the next step is to load the API key, which I have set in my env file. So this is how I will load the OpenAI API key because it is required to query OpenAI. And if you remember, this was the content that we wrote in the last session and we did query on top of it. So I'm showing you with a similar content, exact same content, that how it will work with LangChain. So this is how we'll set the content. And the next step was to split the content into smaller pieces, right? So for this, LangChain provides you a lot of splitter. Like if you remember in the previous session, we wrote the splitter ourselves, but LangChain provides you a lot of splitter, out of which we are using recursive character text splitter. So what it does is very simple. It just keeps the paragraphs and sentences intact in the text document, right? So you can read more about it into this document that they have. I will add this link. But yeah, so we are using this recursive character text splitter, which attempts to keep the larger unit, like the paragraphs or things intact, so that content from the same paragraph are not divided into two different chunks, which will create different outputs, right? So this is what we'll use here. So this is the first advantage of using LangChain, where it provides a lot of inbuilt text splitter. Like you can also build it, but it has provided it out of the box, right? Then what we'll do is we'll create documents using it. So basically, once we have splitted it, we'll convert it into a document format, which is more sort of LangChain term, right? And then we'll just run it. You can see it, how it has divided it into 10 chunks. And each chunk has a section like this. You can see each sentence is inside this, and so on, right? So now, once we have divided it, the next step was, if you remember from the previous session, the next step was to convert those chunks into embeddings and store it in VectorDB. So here comes the next advantage of using LangChain. It provides you a simple method, OpenAI embeddings, and you can just call this method chroma.fromDocuments, and it will automatically convert every document into embedding and store it into your DB, right? Well, you just need to pass the OpenAI API key for that, right? So we'll see how easy it is here. Yeah, so we can see that a Chroma folder has been created where our data, which the whole chunks, all the chunks are converted into embeddings and they are stored into that DB folder, right? So we have moved all the data to ChromaDB. Now the next step was, if you remember from the previous session, the next step that we did was, after loading the content, I'm just opening it here, store the chunks in DB. The next step was to query the vector DB, right? So that is also very simple with LangChain. You just need to do vector db.asRetriever, and you just need to pass how many items you need to pick up. Like if k is 3, it will pick the 3 most relevant items. If k is 5, it will pick 5 most relevant items, right? And if you just call it retriever.getRelevantDocuments, it will give you that. See how simple it is. I can see I gave a query who is the life partner of Kohli, and it gave all the relevant documents, like he's credited with this. Kohli is married to Bollywood actress Anushka. So it was able to find out the relevant context out of it, right? And now once we have the relevant context, we can simply pass it to the LLM. to get our actual answer. Like that is also very simple using LangChain. Like you can just create a chat, call this chat OpenAI class constructor, and then I just need to call retrieval QA dot from chain type, where I will pass the LLM, I'll pass the retriever, I will set some variables, some flags, and I will just call QA chain with a query, and that's it. It will give me the output like you can see here. So it is entering the retrieval chain. It has finished the chain, and the answer is so basically what it did, we gave these three relevant documents to the LLM, and it was able to curate this answer for us. That's it. So yeah, we saw how LangChain made the same process simpler. So it removed a lot of complexity, like it removed custom writing of code for text splitting, storing into DB, then embedding the data, then finding the relevant data, right? Another advantage of using LangChain or any similar library like Llama Index is instead of OpenAI embeddings, I can use any other embedding, like if any other model I have to use for embedding, I just need to replace this class and that's it, right? And it will automatically start using that embeddings. Similarly, if I have to use any other DB, I just need to use pinecone.from documents. It will start using that DB, right? I don't need to write anything else for that. And then if I have to do the next step, if I'll show you, if I'm using a different DB also, it will this function is going to be same. Vector db.as retriever, then get relevant documents method will always be same for you. So this is another advantage of using a library. It removes the complexity of changing the model, changing the vector db, changing the embedding model. Very simple. Like you can replace it without changing a lot in your code. So that was all for this section where we saw how to do the same thing that we did in the last session using LangChain. Now let me show you a little complex example of like a RAG pipeline using LangChain. So in this example, what we'll do is we'll load some URLs. Like let's say there is a Wikipedia URL about Kohli, about Dhoni, and you want to load all of them, and then you want to query on top of it to answer something, right? Like you want to load any custom data of yourself and you want LLM to do query on top of it. How will you do that? So LangChain makes that also very easy. You just need to use a web-based loader, and then you just need to define all the URLs here. Like I have defined just two. You can define any number of URLs here, 10, 20, anything, right? And then you just need to load that. So what loader.load will do, it will just load all the data from all these pages and bring it for you. Like if you remember in the previous section, we hard coded the data here, right? But now we are bringing it from actual URLs, right? And then loading it. And then we can use same splitter like this. I'll quickly run it. And the next step is that we are using the same text splitter to split that document into smaller chunks. So this time, since the document is big, the number of chunks is also 716. And then we'll also run this, which will convert those into embeddings and store it into our vector DB, right? And once the data is stored into the vector DB, we all know that we can do a query like this always, right? And we can find the relevant output from the vector DB. Like in this case, it was able to find this data, then this is also a relevant data, and this is also a relevant data, right? It was able to figure out that. And then if you search, then we can pass the same query to LLM very simply like this, and it will get all these relevant documents, and it will be able to answer the question that we asked, right? So this is how we can load complex documents from URLs and then build a RAG pipeline on top of it to query anything that we want. Now, let's say we want to increase the number of relevant documents. This is how I can do that. I just need to set k equals to 5. We'll do this, right? So this is how it works. And this is how you can build a RAG pipeline, a little complex one, where you're loading data from different sources like web-based loader. Then you have different types of loader as well, which you can use. Like you can load data from Google Drive, you can load data from Sheets, Google Docs, anything else that you can think of. there is a loader at LangChain for all those things. So yeah, that was all for today's session where we learned about how to do RAG with LangChain with a simple example and a complex example as well. And in the next session, we are going to start a very interesting module that is going to be on AI agents, where we are going to learn how to build AI agents from scratch, what is AI agents first, how to build that from scratch using code, and we'll also build AI agents without using any code. So make sure you subscribe to this channel and follow this series. And if you have any feedback, if you like this video, make sure you share this with your friends or in your groups or in your community so that everyone is able to learn this GenAI thing from scratch. Thank you so much for watching this.